Hello, my name is Franklin Maxwell, and on November 30th, I went to the Physics of Breakfast lecture held by Peter Juncker. So, Mr. Juncker started out by saying that physics is all around us, and especially in the things that we eat for breakfast. He used three examples: coffee, eggs, and cereal, and which he used the coffee ring effect, how scrambled eggs occurs, and the cereal effect to describe how cereals behaves in water, or milk, rather. So for the coffee effect, what he called it was a coffee ring effect, and the principle is how when you drop a coffee onto a piece of paper, it dries faster on the outside than on the inside. This is really noticeable because there's the dark ring on the outside. However, it was not sure why this was so and why it would not smooth over the paper. And so it comes through when the coffee is filtered, the oils and water, the oils from the coffee beans and the water mix. And this is rather strange because most oils are not water soluble. However, the ones in coffee are. And so they mix and go into coffee. When you drop it, the oils in the water and coffee react in a way that they want to minimize the surface area with increase the surface tension. And so the molecules on the outside want to attract the more molecules that they can towards them. And so when the molecules on the outside evaporate and dry, the diameter is sealed within the ring of the drop. And so the molecules on the inside that want to be drawn towards the outside are pushed towards the outside, or flow towards the outside rather, with the adhesion and cohesion of the surface that it is on. This eventually leads to more molecules being on the outside of the ring than the inside, hence why there's a darker stain on the outside. So for the scrambled eggs, what he discussed was why when you scramble eggs or heat them up, they turn into a solid, where most things like ice would turn into a liquid, because when you heat up ice, it clearly melts. So to test this out, he used a universal testing machine to decide whether eggs are really solid or liquid. This universal testing machine uses a creep test and measures the force necessary to push down on something. So he did this with eggs and found out that they are very elastic. This is because the eggs and the proteins that make up the cells that make up us as well have many different types of cells, hydrophilic and hydrophobic cells in the structure. So when they're heated up and they denature, when they refold back into different structures, they refold in incredibly different ways than they did before they were heated up in nature. He compared it to Velcro, and how heating the proteins is opening up the Velcro, and then they denature and unfold, and then mix all around, and so that after that it's nothing like the original. There's the one soft side and the one hard side, which are not alike. Original seal. So the third thing he talked about was Cheerios, and how since Cheerios are less dense than the milk you put them in, they want to rise to the top of the surface, or float pretty much. And he talked about how was the adhesion of the Cheerios creates a meniscus around them, and so that other Cheerios can essentially ride up this meniscus of the one Cheerio in the milk to essentially get on top of that other Cheerio. This is known as the Cheerios effect, and looks like two Cheerios attacking each other to get up on top. So at the end, he kind of discussed what some of the practical purposes were, which is what I found very interesting. He was talking about how malaria tests and Alzheimer's tests were done with dried. You had the results from within a dried drop of the blood or testing solution that is put on, and then you have to wait for it to dry to get it. And the principles with the coffee ring drawing can be eventually used in helping the ease and simplicity of Alzheimer's test and malaria test worldwide, which I found was very interesting. Thank you for your time.